In this video, we're going to be talking about interpreting and communicating the results of statistical analysis. So it's basically the time for the interpreting part of the chapter. So let's go ahead and let's take a look at an example. So a university conducted an investigation of the amount of time required to enter the information contained in an application for admissions into the university computer system. Now, one of the individuals who performs this task was asked to note starting time and completing time for 50 randomly selected application forms. The resulting entry times in minutes were summarized using the mean, median, and standard deviation. Here we have a mean of 7.854, the median of 7.423, and a standard deviation of 2.129. So what does this tell us? Well, the average time required to enter admissions data was 7.854 minutes, but the relatively large standard deviation suggests that many observations differ substantially from this mean. The median tells us that half of the applications required less than 7.423 minutes to enter, and the fact that the mean exceeds the median suggests that some unusually large values in the dataset affected the value of the mean. And this last conjecture is confirmed by the 7-leaf display that we see here. Notice that 14.3. So the administrators conducting the data entry study looked at the outlier of 14.3 minutes and at the other relatively large values in the data set. And they found that the 5 largest values came from applications that were entered before lunch. And then after talking with the individual who entered the data, the administrators speculated that morning entry times might differ from afternoon entry times because there tended to be more distractions and interruptions, meaning phone calls and stuff like that, during the morning hours, when the admissions office generally was busier. Let's move on and let's talk about what to look for in published data. So really we want to know, what are these fools trying to say? So there's a few questions to ask yourself when you interpret numerical summary measures. Is it an appropriate summary? Meaning, is the chosen summary measure appropriate for the type of data collected? In particular, you want to watch for inappropriate use of the mean and the standard deviation with categorical data that has simply been coded numerically. The mean and the median. If both the mean and the median are reported, how do the two values compare? What does this suggest about the distribution of values in the data set? If only the mean and the median are used, was the appropriate measure selected? I want to know, how big is that standard deviation? Is the standard deviation large? Is it small? Is the value consistent with your expectations regarding variability? What does the value of the standard deviation tell you about the variable being summarized? And then Chebyshev's empire. Can anything of interest be said about the values in the data set by applying Chebyshev's rule or the empirical rule? Remember, Chebyshev's empire or rule can be used for any data set, but the empirical rule can only be used for normal distributions. So we have a word to the wise here. We've got some cautions, we've got some limitations. Malcolm isn't all that matters. If you remember that show Malcolm in the Middle, yep. So measures of central, like the centers, they don't tell all. Although measures of centers such as the mean and the median do give us a sense of what might be considered a typical value for a variable, this is only one characteristic of the data set. And without additional information about variability and distributive shape, we don't really know much about the behavior of the variable. Sometimes even using more numbers isn't enough. Data distributions with different shapes can have the same mean and standard deviation. Take a look at these histograms right here. Both histograms summarize data sets that have a mean of 10 and a standard deviation of 2, yet they have completely different shapes. You want to know, is it skewed? Both the mean and the standard deviation are sensitive to extreme values in a data set. especially if the sample size is small. If a data distribution is skewed, or if the dataset has outliers, the median and the interquartile range may be a better choice for describing the center and the spread. We're not talking about height. Measures of center and variability describe the value of the variables studied, not the frequencies in a frequency distribution or the heights of the bars in a histogram. Take a look at the two histograms, the frequency distribution and that histogram. There's more variability in the data summarized in the histogram for A than in the histogram for B. And this is because the values of the variables described by histogram B are more concentrated near the mean than are the values for the variable described by histogram A. Don't be misled by the fact that there is no variability in the frequencies in histogram A, in the heights of those bars for histogram A. Don't carry empty boxes. Be careful with your box plots based on small sample sizes. Box plots convey information about center, variability, and shape, but when the sample size is small, you should be hesitant to overinterpret the shape information. Is it really not possible to decipher, it really is not possible to decide whether a data distribution is symmetric or skewed if only a small sample of observations from that distribution are available, kind of making it an empty box. Also, not everything is normal, or even approximately normal. So you want to be cautious in applying the empirical rule in situations in which you're not convinced that the data distribution is at least approximately normal. Using the empirical rule in such situations can lead to incorrect statements. And outliers are bad or good. So you want to watch out for outliers. Unusual observations in a data set often provide important information about the variable under study. So it's important to consider outliers in addition to describing what is typical. Outliers can also be problematic, both because the value of some descriptive measures are influenced by outliers and because some of the methods for drawing conclusions from data may not be appropriate if the data set has outliers. So we've talked about what to look for in published data. We've talked about interpreting the results of statistical analysis, and we've gone over some cautions and some limitations to help you be better at interpreting and communicating the results of statistical analysis.